Hey everyone, and welcome to this explainer. Today we are on a mission to really demystify enterprise security infrastructure. We're going to do this by zooming all the way in, starting up at the macro level with your broad network walls and going all the way down to the micro level, looking at the literal locks on individual files. By the time we wrap up this journey, you're going to see exactly how all these different layers of security stack up to keep an enterprise's data safely locked down.
Here's our roadmap for today. We'll start with dividing your network, explain access control lists, and then look at some real-world ACL department rules. After that, we'll map things to the OSI model layers, compare Windows and Linux permissions, and finally, wrap things up with some security best practices. Let's dive right in. All right, Section 1, dividing your network. So, I want you to imagine the sheer chaos of a completely flat network architecture. Seriously, think about it. If just one single HR laptop gets breached, lateral movement for an attacker is trivial. Because there are no internal boundaries, that one compromised host suddenly has a direct line of sight to, well, everything. Your finance servers, your dev databases, the whole shebang. A single compromised host can literally bring down the entire system because there is absolutely nothing standing in its way once it gets past the perimeter. And you know, that is exactly why we rely on segmentation. By carving up that flat network into distinct subnetworks, we immediately confine the blast radius of a breach. So that compromised HR laptop we just talked about, its reach hits a brick wall right at the border of the HR subnetwork. It can't touch the rest of the enterprise. Now, a quick caveat. To do this correctly, administrators really need to intimately understand the organization's data flows and business needs. You have to make sure these divisions are boosting security without, actually breaking the business in the process. Moving right along to Section 2, access control lists explained.
Now, right at those segment checkpoints we just created, that's where we enforce access control. This is basically the core mandate of security management, selectively restricting resources so that only authorized users and services can actually get through. You want absolute 100% certainty that only the right people and the right systems are getting their hands on specific resources.
So how do we actually do this? Well, we enforce this digitally using access control lists, or ACLs for short. Think of these as the configured rulebooks sitting right at your network boundaries. They're making these very strict grant or deny decisions based on specific IPs, protocols, or ports.
Which brings us to Section 3, real-world ACL department rules.
Let's ground this with an example. Look at this finance department subnet, kind of like a bouncer checking IDs at an exclusive club. To protect that highly sensitive financial data, the rules are incredibly explicit. Allow inbound traffic from authorized finance workstations. Deny human resources. Deny development. Basically, if you don't work in finance, you're not getting in. But take a look at that final rule on the list. We still allow necessary general access to shared resources, so the whole company can still check their email and browse the internet, while the truly sensitive stuff stays completely locked down.
Section 4, the OSI model layers.
Now, what's really cool is that these ACL rulebooks can operate at different depths of the OSI model. Down at Layer 2, the data link layer, we can filter traffic physically using MAC addresses. As we move up the stack to Layer 3, the network layer, we start filtering logically with IPv4, IPv6, or even raw IP protocols like OSPF or ESP. And if we go up to Layer 4, the transport layer, we can get incredibly granular. Here we're filtering specific upper layer packets based on TCP or UDP ports, evaluating the exact source and destination of the traffic. Next up is Section 5, Windows versus Linux permissions.
Okay, let's zoom all the way in now, down to the actual file and folder level. This is where we rely on permissions. If ACLs are the doors to the building, permissions are the final padlocks on the individual treasure chests of data. They ensure precise authorization to read, write, or execute files. This is how we make absolutely sure users are only interacting with the exact resources strictly necessary for their specific roles. As you might expect, the two major operating systems handle these locks pretty differently. Windows uses security identifiers, or SIDs, to represent users and groups. It relies really heavily on a pretty complex system where child objects inherit permissions from parent containers. Linux, on the flip side, employs a simpler but highly effective structure. It strictly categorizes access into 3 distinct buckets: the owner of the file, the group the file belongs to, and others. Honestly, the sheer elegance of Linux lies in its octal values. It's just simple math. Read gets a value of 4, write is 2, and execute is 1. By just summing these numbers up, administrators can assign exact rights instantly. So if you see a 7, that just means 4 plus 2 plus 1. You get full read, write, and execute privileges, all communicated in a single digit. To actually wield this control, administrators rely on a standard toolkit. You've got LSLEL for visibility into your current permissions, CHOOD for making modifications, and CHOWN or CHGRP to handle ownership transfers. And for those tricky edge cases, you can use special permissions like SUID, SGID, or the sticky bit to provide an extra layer of granular control over the standard privilege sets. Finally, Section 6, Security Best Practices. Bringing it all together across both environments, there are a few golden rules you absolutely need to follow. In Windows, always grant permissions to security groups rather than individual users. Doing it user by user is a quick path to administrative nightmares and system performance drags. In Linux, the best practice is to strictly manage your user and group ownerships using chown and CHRGP. This gives you a really tight grip on exactly who controls what data. Doing this systematically is what keeps your infrastructure both secure and functional. So, we've covered a lot. We've seen how to build the walls, lock the doors, and secure the treasure chests. But as we wrap up this explainer, I want to leave you with one final provocative thought. Let's say your network is beautifully segmented. Your access control lists are tightly configured. Your granular file permissions are flawlessly set across both Windows and Linux. Everything looks perfect. But who is monitoring the rule makers? You see, securing an enterprise network isn't just a set it and forget it kind of task. It requires constant oversight, continuous auditing, and relentless curiosity to make sure those carefully crafted rules actually hold up against tomorrow's threats. Think about it. Thanks for joining me on this explainer. Keep exploring and stay secure.